Hello and welcome to today's webinar on sun care in a heating world, the latest roundtable webinar from Cosmetics Business. I'm Julia Ray, I'm Head of Editorial at HBCR Media, and I'll be your moderator for this session. 2023 was Earth's hottest year since records began. But what exactly does that mean for those of us who make sun care, or indeed UV protecting products in any category? And how do we meet the challenge of a heating environment amid the regulatory changes surrounding UV filters, which are reducing scientists' sun safety palette? What tools does the industry need in order to respond to these parallel challenges? To help us get some insight and perspective on this, we have a fantastic group of experts. But before I hand over, I'd like to mention a few housekeeping details. Firstly, today's webinar will be available on demand if you would like to revisit or share the content at any stage. And the last 20 minutes or so of this webinar will be devoted to a Q&A session. So do feel free to ask our experts anything that you like. You'll see a box for questions in front of you. So do use this to send any questions that you haven't already sent in to us as part of our sign-up process. So with all of that said, I'll now hand over to our first panelist.
Hello, my name is Miriam Son. I work at BASF in the Global Technical Center Sun Care. Welcome to my presentation, which is entitled Safe in the Sun, Inside in Tomorrow's Sunscreen for a Better Photoprotection. So I would like to give you some guidelines how we can yet improve the performance of today's sunscreen. But first, what are the consumer expectations? So these are twofold. First, they are wait for a better protection for themselves, but also for the environment, using, for example, sunscreen that are less aquatoxic or less bioaccumulative, more biodegradable. But first, how can we yet improve the performance of today's sunscreen for a better photoprotection? The European Commission gives recommendations about the performance that are allowed to be claimed on the sunscreen product in Europe. It provides the categories of the SPF values, but also the minimum UVA protection a sunscreen should afford, which is 1/3 of the SPF value. But first, regarding the SPF, the maximum limit is fixed in Europe to 50+. And what we can see on the histogram is that the number of products increases with high and very high SPF claims, so the bars in orange. And we even observed that over the last 10 years, 100% increase of the number of products with SPF 50 or higher. And on the other side, there is no evolution of the minimum UVA protection requirement since 2006. So the question is if we give too much attention to the increase of the SPF, and on the other side, maybe too less attention to the increase of the UVA protection. And so coming back some 30 years ago, Professor Diffie in San Antonio in 1991 made wise and precursor advice, which was to encourage the development of sunscreens which absorb more or less uniformly throughout the full UV spectrum. Of course, since 1991, significant progress has been done in terms of UVA protection. Indeed, standard methods have been developed to measure the UVA protection of sunscreens. However, today there is not yet a single and harmonized UVA protection claims like it is, for example, for the SPF. And different regions are using different UVA protection claims. So the question arises, what do this level of UVA protection really afford for? And if the today's UVA protection is actually sufficient? So to answer this question, we first need to define what would be an ideal protection. So it seems rational to say that an ideal protection would be to reduce the intensity, but without modifying the spectrum of the natural sun reaching our skin. And this ideal protection can be obtained by fabrics, for example. So the figure here shows the transmission of light depending on the fabric color. And in green is highlight our UV range. And what we can see is that less than 10% of UV is transmitted for most of the fabrics, and that even less than 1% is transmitted for black fabric. So the figure here shows the transmission of a typical SPF 30 sunscreen in orange with a UVA protection of 1/3 to the SPF, and this is a typical UVA standard in many countries. And in comparison, the curve in black is the UV transmittance of the fabric, which would be the ideal photoprotection. Compared to fabric, the UV transmission of the sunscreen with a UVA protection of 1 to 3, it is much higher in the UVA range, so from 370 nanometer, and more than 40% of UVA1 is transmitted. So what we can say is that the spectrum is very balanced in the UVA1 range, and we can say that the current sunscreens are far from being ideal in the UVA range. So the goal for better and safer photoprotection would be to come closer to the fabric by improving the UVA1 protection. The curve in blue here is the transmission curve of a sunscreen which has a UVA protection of 5 stars. So the star rating system is a UVA methodology that is used in the UK, and the highest level of protection is provided by 5 stars. So as you can see here, there is a significant improvement in the UVA protection, so especially in the UVA1 protection for sunscreen with 5 stars compared to sunscreen with a UVA PF SPF ratio of 1 to 3. So a 5-star UV protection would correspond to a UVA PF SPF ratio of around 2/3. So this is the green line in the figure. And what you can see is that you can significantly reduce the transmission between 380 to 400 nanometer from more than 40% for a ratio 1 to 3 to around 20% for a ratio of 2/3. So we come closer to the ideal protection of fabrics. And to the question if it's possible, yes, it's possible to get a better UVA protection than just the minimum requirement of a UVA PF SPF ratio of 1/3. And some market products already did this and highlight this. But why is UVA1 protection important? So we know that there is less variation in the UVA than in the UVB intensity throughout the year and the time in the day. And UVA radiation penetrates skin more deeply and causes different multiple damages there. They modulate the gene and protein expression, so like reduction of the immune system response, of the DNA repair systems, like anti-inflammation, or also pigmentation disorders like hyperpigmentation. And these alterations occur already as suberythemal doses and are visible only years after the exposure. So yes, better UVA protection is more than just an anti-aging benefit. So the next question, is it technically feasible to obtain the UVA protection that is higher than 1/3 of the SPF value? So here an example, when you use the same pool of UV filters, so UV filters that are registered in Europe and in many other countries, you can obtain a sunscreen with the same SPF, but that shows different absorbance profiles. So here we have an example with combination 1 in green or combination 2 in orange. So both combinations are based on the same core filter system consisting of UV-Null A+, a UVA filter, Tinosorbes, a broad spectrum, and UV-Null T150, a UVB filter. The three filters are photostable. But Tinosorb A2B, which is present in combination 1, which is a UVB UVA2 filters, is exchanged in combination 2 with PBSA, which is a UVB water-soluble filter. So both sunscreens show the same calculated SPF, which is around 30. Both combinations use the same percentage of filters and the same number of filters. but what we can see is that they highly differ in the value of their UVA protection factor, which is around 20 for combination 1 and 10 for combination 2. So combination 1 would have a UVA-PF SPF ratio of around 2/3, whereas combination 2 is a typical sunscreen with the requirements of UVA-PF SPF of 1/3. So to the question if it's possible to develop sunscreen with a higher UVA protection, so the answer is yes. With the current filter palette, it's possible to develop sunscreen with more uniform protection. And now a second aspect consumers are more and more sensitive to is the environmental aspect of their sunscreens. To meet this demand, BASF developed a tool, which is the EcoSun Pass, which considers 8 different parameters to cover all relevant environmental compartments. And thanks to this tool, it is possible now to develop more eco-compliant sunscreens. And here is an example of a formulation, SPF 30, which fulfills both better UVA protection with a rating of 5 stars and fulfilling the UVA PF SPF of 2/3, and also fulfilling the criterion of the EcoSun Pass methodology. So to summarize, consumers are interested in sunscreens that are efficient and safe for their own, but also for the planet's health. Ideal UV protection is provided by fabric, and increasing the UVA protection, especially the UVA1 protection, this is the first way to approach this ideal protection. So achieving a ratio of 2/3 may be a first step. And finally, the EcoSun Pass tool offers a possibility to design a more eco-compliant sunscreens. And I would like to finish thanking some colleagues for contributing to this presentation, and thanks to you for your interest in the topic. And now I'm looking forward to your question in the Q&A part.
Hello, everyone. My name is Chelsea Mejia, and I'm here on behalf of Eurofins CRL Cosmetics, Inc. I'm happy to be a part of this discussion about sun care in a heating world with the Cosmetic Business Roundtable. I am currently the photobiology manager here at Eurofins CRL, located in Winston-Salem, North Carolina, and I oversee the daily clinical testing operations of R&D sun-protecting products. I have over 7 years of experience in the SPF industry. Here at our SPF lab, we perform all in vivo and in vitro testing for FDA, ISO, and Australian New Zealand monograph. Myself and my technicians are not formulators, but we are able to offer insight on many aspects of SPF formulas, such as product consistency, is it sticky, thick, too oily? How stable is the product while being stored at our site during testing, meaning have the ingredients separated? And how does the product feel when it is applied to the skin? Does it absorb too quickly or does it sit on top? Over the years, there have been many changes that have occurred to the testing monographs, but not so much in regard to actual testing procedures. The FDA has been in discussion for years about banning certain UV filters, and we still have not heard a date for an estimated final decision. To formulate a performing sunscreen, the product must have protection over all of UVB and just over half of UVA. UVA is testing for pigmentation or darkening, and the UV filters support the critical wavelength of the product. UVB is testing for erythema or sunburn, and the UVB filters support the actual SPF protection of the product. Both UVA and UVB filters are needed to formulate a product providing protection against the full spectrum, meaning all of UVA and UVB. There is definitely a trend on mineral-based sunscreens as manufacturers are still unsure about the UV filters that will or will not be allowed once a final decision has been made by the FDA. It is not easy to formulate a sunscreen meeting both UVB and UVA needs, especially when wanting a high SPF performing product such as an SPF 50. Mineral sunscreens are also a huge part of the sunscreen testing world. Formulators are always trying to come up with a way to formulate using ingredients such as coconut oil, jojoba oil, and sunflower oil. You may be asking yourself, how is UVA performance tested? Here at our photobiology lab, we have in vitro testing, which is testing on substrate plates to obtain an in vitro estimated UVB or UVA value. And we also have in vivo testing, which is testing on humans. We prefer to start with a 5-subject screening panel, and during this time, we can adjust the SPF level on each subject in order to give you a good actual data point. If the product is performing as expected and you intend to market this sample, then you will need to end with 10 valid subjects in order to make an SPF claim. We also offer UPF testing, which is an in vitro type of test, which is testing the sun protection level of the shirts, bathing suits, and hats that we all wear to protect ourselves at the beach and pools. Our Texas lab is able to offer antimicrobial efficacy testing, which is basically the same, but just testing the antimicrobial efficacy of the fabrics containing UV. You may also be wondering, how do we ensure that all labs are doing the same procedures? Each year, Eurofins has an internal ring study where all of our labs participate and we compare our results. Most of us also participate in a BIPIA ring study. BIPIA sends all of the SPF labs the same products. We perform the testing and then submit our results to compare and ensure accuracy throughout all participating labs. I am happy to say that Eurofins CRL in North Carolina has the largest number of trained photobiology technicians when comparing to other participating labs. Now let's talk about white cast. We often see issues with formulating a performing SPF product without leaving white cast on the skin after application. As most of us know, zinc is the #1 ingredient found in most sunscreen formulations. The higher the percentage of zinc usually correlates to a more prominent white cast. Consumers and manufacturers alike both want a product that protects the skin from the sun but leaves no residual white cast. Clients often submit the same formulation with different levels of zinc to try and pinpoint an effective SPF product. We have seen a large uptick in clients that are interested in formulating sunscreens that do not cause a white cast, specifically for African Americans or other skin types 5 and 6. White cast testing can be performed on all skin types, but SPF testing is specific to skin types 1, 2, and 3. If you are interested in pigmentation testing on skin types 3, 4, and 5, then we do offer UVA-PF testing, but those are the only test types that are available to darker skin types. In the future, we are moving towards testing on all skin types to ensure that the products are working on skin types 1 through 6 and even above. Is sweat-resistant testing needed? So sweat-resistant testing was replaced with water-resistant testing with the assumption that if the test product could withstand the 40 or 80-minute tub immersions, which is more strenuous, then the product would be considered sweat-resistant as well. Some argue that water and sweat-resistant testing are not comparable because sweat can break down the water-resistant components of a formula. Sweat-resistant properties of a formulation tend to closely follow the water-resistant formula. However, the test does not substitute for the water-resistant claim incorporated in the SPF test protocols. So is this considered the same as sweat-resistant if the product is applied and then sweat is produced from the body, versus water-resistant testing where the product is applied and then the water is gently agitated, simulating a swimming pool? I don't know, that's something that everybody talks about all the time of how did this replace one another, but again, sweat resistant cannot replace water resistant, but water resistant can replace your sweat resistant claim. Here we have an example of a non-sweat resistant sample during testing. You can see that the sweat has caused the product to be removed from the skin. Therefore, this would be considered not sweat resistant. And I want to thank you for your time. Please feel free to contact me with any questions that you may have, or if you are interested in testing with us. Here in North Carolina, as well as Texas and New Jersey, we offer a huge array of testing. We'd be happy to work with you. Again, my name is Chelsea Mejia. I'm the photobiology manager at Eurofins CRL in Winston-Salem, North Carolina. Please feel free to reach me at this information on the screen if you have any questions or you are interested in testing. Thank you.
Welcome everyone. Today the Symrise cosmetic ingredient team is happy to share with you their latest findings and solutions to address the growing concern of sun and heat-induced damages. First of all, I will introduce you the context and explain you this new concept of urban heat islands. Then Eve will introduce our solution against the sun-induced damages, and I will finish with the heat-induced protection and our solutions. So first of all, as we are all well aware now, the human activities triggered global warming, and we are all exposed now to more and more extreme climate phenomena that are coming more frequently, and especially hotter temperature and heat waves. So the new concept of urban heat island is coming from the fact that in big cities and urban environment, buildings and roads can absorb and re-emit the sun heat more and more. And where the structures are highly concentrated and greenery is limited, big cities are becoming islands of higher temperature, where the temperature is very high during the day and can reach 45 degrees, but also during the night. And the fact that during the night the temperature cannot cool down is triggering this heat island effect. And this effect will be more and more present in the future. Today, 50% of the global population lives in urban area, and we know that by 2050, it will even reach 70%. So what happened to us and what happened to our skin during these heat waves is now better studied and better documented, and famous dermatologists and professors of dermatology are studying the impact of the climate and climate-induced skin damages. What is very important for the cosmetic industry is the fact that auto-inflammatory diseases are observed during heat waves, but also have impact on skin cancer and heart condition. People with brown or let's say dark phototypes will be facing photoaging, and change of the texture and wrinkles are also observed on the population exposed to heat waves. I now hand over to Eve, who is going to introduce you our solution against heat and sun damages concerns.
Thank you, Marielle. So when we are talking about our solutions, we consider at first the basic protection, meaning UV protection. And we have seen so far that face care products are growing, and especially with using more UV filters and a higher SPF. So heat-induced skin issues have also an impact on skin when it comes to eczema and oily skin. And here we have or should combine the UV filters, the right choice of UV filters, and the right active ingredients to improve the impact on the well-being in the fact that the ingredients are used improves the freshness of the formulation and gives also a mental health. So to have an impact on the formulations means also to improve formulations with ingredients which have a positive impact on the efficacy. So SPF boosters could be used, ingredients could be used which have an impact on the incorporation of active ingredients, but also on the UV filters. And here it's also important to use the right ingredients to reduce the heat-induced pigmentations. On the next slide, I will go a little bit more in detail what we mean.
Sorry, it doesn't move. Yep.
Now coming to the solutions from our end, and at first a briefly introduction about the UV protection. So why it is so important? It is because the solar radiation is really huge. It's coming from UVB, UVA, visible light, infrared, and so on. And all these rays have an impact on the skin. So when we are talking about UVB radiation, everyone is aware we are talking about burning and sunburn. If it's up to UVA, it's aging, and we'd like to keep the healthiness of the skin. And here, for the formulation, it's important to use the right combination of UV filters, like minerals, titanium dioxide or zinc oxide, or like organic UV filters. But in the current situation, it is also important to adapt this kind of formulation to improve the efficacy, to boost the SPF, meaning to have a higher SPF as in the past, to solubilize the used ingredients as good as possible to increase also the efficacy of the formulation, and also to keep the formulation to have a water resistancy improvement and also a sweating improvement. So here it's really important to use the right choice of basic ingredients, but the most important is to keep an eye on our solution on the active side.
So additionally to the UV filters and to the solution to address the direct damages caused by sun, it's also very key to understand and to address all the other impacts of and damages caused by exposure to heat directly. So at Simrise, we have developed a platform of solution against heat-induced skin issues, starting with eczema-prone skin and oily skin issues. And we have clinically proven ingredient to address these concerns. But also impact of well-being of consumer will be more and more important in future. And our Frescolat range is the perfect solution, as we have demonstrated the fact that the use of Frescolat and application of Frescolat in formulation can decrease the temperature at the surface of the skin, and also how to affect and how to boost the mood and how to support consumer in regard to their sleep disorder is also something that we wanted to address with our solution. And finally, we have a full range of ingredients to address the issue of hyperpigmentation that is triggered by exposure to heat. This last part has been developed together with Professor Jean Krootman from the EUF, and Professor Jean Krootman was able to demonstrate the fact that during heat waves, phototype with the higher range of phototype are exposed to hyperpigmentation and pigmentation disorder when they are exposed to heat. And he has developed a new ex vivo model to assess the efficacy of cosmetic ingredient. And on this graph, you see that ex vivo explant exposed to a temperature of 37 degrees observe an increase of their pigmentation. And with one of our ingredients, Simbright FA, this hyperpigmentation can be modulated. If you want to learn more and if you have any question, please don't hesitate to visit our SimSelect website and also to address all your questions now. Thank you very much.
Hello and welcome to the live Q&A session of this roundtable webinar. We hope that you've been inspired and educated by all of today's presentations. If you'd like to know anything further, now is your chance to send in your questions for our panelists on all things sun care related. And I can see that some of you already have today, which is excellent, and others, of course, sent in questions as part of the registration process. So we will attempt to answer as many questions as possible in the next 20 or 30 minutes or so. So to begin, we have one coming in here on consumer compliance, asking how can we get consumers to perceive sun care as a necessary part of their skincare routine? Who would like to answer that one? Maybe Eve or Marielle?
Yes, I can take over if you like. So yes, this question is of course very interesting because we always ask the same question to ourselves. So we would say that yes, we have to train our consumer. We have to be more active on social media, for example, to make them aware that sun protection is not only for going to the beach. It's also a daily care, and to apply it as often as possible if you go out in your garden or if you only go through the street. So here we really need to educate our people, and maybe it's something to bring it also to the schools, to make already the teenager aware to take care about the skin, to protect the skin. And yes, so we have a lot to do, but I think thanks to social media, it could be also easier to spray it around and to make more advantage of this.
To raise awareness at that young age.
Can I maybe?
Oh, please, yeah, jump in.
Thank you. Thanks, for what you said. You're totally right. I guess it's the education that is a part, but also from the scientific point of view, we gained a lot of knowledge, and we know that suberythemal doses today are also responsible of the long-term effects. So consumers often look for protecting against the erythema because it's what is visible. But now we know 20 years after experience and the first sunscreens that lack on this UVA protection, that the damage of UVA protection appears now, like the wrinkle and the skin cancer contribution. So this is an educational part to make it known that suberythemal doses also are responsible, and that's why it should be part of a daily routine.
Absolutely.
Thank you.
So we've got a question that's come in here asking, what UV filters have the best safety profile? Anybody want to jump in and answer that?
I can comment. Yeah, rapidly, because we are producer of the filter, so we are very well in process. So what I would like to say, it's safety, can be related or seen like human safety. Of course, it's the first aspect we think about. The second aspect would be environmental safety, that is more and more discussed. But regarding the human safety, it's important to say that all filters are registered, so they need to go through a very tough approval process before they are allowed to be used. So it's a series of tough tests, toxicological tests, that a molecule must go through. So each filter actually that is registered is safe, and there are some reviews in time when new data appear. Nevertheless, we can say that the inherent properties of the UV filters can differ, so like the molecular weight. And we know that the molecular weight is one important factor for dermal penetration. And in the pharmaceutical field, a threshold of 500 Dalton is used as a threshold for penetration, because in the pharmaceutical field, we want the molecule to penetrate. For the sunscreen is the opposite. We want them to stay on the skin surface to absorb the UV. And so often these 500 Dalton that differs between the filter molecule can be seen as has a threshold, not the filters not to penetrate. So this is maybe a difference between the filter molecules that we have, as well as the photostability, for example. So filters can be photostable or less photostable. So this will not be seen in the SPF or the UVA performance measurements. But if a filter is not photostable, he will change during the irradiation. So either develop other molecules or even produce free radicals that we know can have some chain reaction in the formulation itself or on the skin, and this is undesirable. So even if each filter is safe for human, there are some properties differences that we can, depending on the skin sensitivity, choose the one or the other molecule.
So there's a lot to take into account, is what you're saying. So I've got a question that's come in asking, are solid sun care formats expected to grow? Chelsea, we haven't heard from you yet. Would you like to answer that one?
Absolutely. This is an interesting question. I would say if formulators can come up and make a performing sunscreen in a stick that does not cause a huge white cast, then yes. But that is why most consumers, manufacturers have moved away from the stick type sunscreen, because the only way to get that consistency is to use a lot of zinc, which obviously makes a white cast. So if there is a way to come up with a formula still in stick type without the white cast, then yes. But if not, then I would not say that would be popular in the future.
It's all down to that innovation.
Yes.
And
what the consumers want.
Absolutely. Consumers know what they want, and we have to follow that. So we have a question here asking, please explain in detail how the EcoSun Pass, which was mentioned just then, works. Does anyone want to explain the EcoSun Pass?
I guess I have to take the word.
Yeah, you're the best person for this.
I suppose so. So there is this big trend also moving towards to develop more eco-friendly sunscreen, because we want all to respect and to take care about our planet. And in this trend, the BASF developed a tool, a methodology that is called the EcoSun Pass technology. And this tool is here to evaluate the impact sunscreen may have on the environment. So it's a value that is calculated based on the hazard profile of each single filter. So for each single filter, we evaluated a lot of different environmental relevant parameters. So for example, not only the biodegradability, what some manufacturers are using to speak about eco-friendly, but also the bioaccumulation or the aquatoxicity, chronic, acute, the sediment toxicity. So, and we took all these tests and to evaluate the hazard profile of each filter, and the EcoSun Pass value takes then this hazard profile, but also the performance of the sunscreen in terms of SPF and UVA protection factor, together with the total filter concentration. And so you got a value, and this value is the EcoSun Pass value that indicates you if your sunscreen is eco-compliant. So here it's a tool that allows to make more eco-compliant sunscreens. So the tool is available in the sunscreen simulator. So this is a tool available in the internet where you can calculate the performance of your sunscreen, and you can also get the value of the EcoSun Pass. And we have developed also this methodology really to support our customers in developing more eco-compliant. If you have any further question about the tool, do not hesitate to get in touch with us.
Fantastic. I hope that explains it wonderfully. It does explain it wonderfully to whoever was asking that question, and to maybe give the tool a try as well. So we have a question here, really interesting one. What do you think about sunscreen using only zinc oxide as the UV filter? What are we thinking about that? Does anyone want to answer that one? Or let me know if you want to skip to the next one.
I can take over.
Go for it.
Yes, thank you for this question. It's of course challenging to use only mineral UV filters, especially only zinc oxide. The good thing is you can use nano and non-nano zinc oxide to reach the UVA and UVB balance. But of course, it will be challenging to achieve a high SPF and also a good skin feel. So meaning here it could be that you need additional boosters or performers that you increase the distribution and also the SPF. So SPF 30 is possible, of course. Everything above sometimes needs additional UV filters or anything else. So this especially from my point of view.
Fantastic. Thank you. We've had one through here asking, is having SPF value on makeup misleading or even unsafe when the tested quantity of 2 milligrams per square centimetre is not aligned with the impossible amount worn by users? I mean, we don't walk around caked up like Coco the Clown. So how, is it misleading? Who might want to jump on and answer that? Maybe Chelsea?
Yeah, I can speak on this. For example, for in vivo SPF testing, which is testing on humans, we use the application rate of 2 milligrams. And we're using a 40 centimeter or 50 centimeter square size test site. So just imagine, just a small rectangle of the makeup, concealer, blush, whatever the product is being applied to the subject. Obviously, that is not a direct correlation of how the consumer is going to use the product at home. We don't know if they're just going to pour it on their hands and rub it all over their body, what kind of applicator they're going to use. So, and again, we are using a perfect application technique in the lab. And again, that does not represent how the consumer will use the product. So I don't know if it's so much about safety, but I would highly recommend that, we let the communities know that just because you're using a BB cream or something like that that has an SPF, that does not cover you for the entire day, especially if you're going to be in the sun for an extended period of time. So I don't know if an SPF label on a cosmetic product is absolutely necessary, especially if it's something such as a bronzer or a blush, because you're using it on such a small portion of your body. But again, we are just, doing the testing per the monograph. And unfortunately, that is the application rate that needs to be used. But no, it does not correlate to how the consumer will actually use the product.
Real food for thought there. Apologies for that, tongue-tied. So Eve, you mentioned nano zinc oxide just then. And we've got somebody asking, what are the updates on nano regulations for UV filters? Does anybody want to jump in on the nano regulations?
So I could answer a little bit. So it's still in progress. So there is still not an official decision what kind of measurements to adjust, or the measurements to dedicate it if it's nano or non-nano. So this is still under evaluation, but so far nano and non-nano zinc oxide ingredients are allowed, so it could be used. And the EU Commission is still working on this, what kind of method will be maybe not the global one, but for the European market. So it's still questionable and still ongoing and no solution so far.
Maybe can I just complete the comment? So there was a nano-define consortium created some years ago that made a huge work to put all methods together and to see which one can be used for which purpose, because we have the EU Commission definition who clearly states how to identify if a material is nano or non-nano. So we need the method, as was mentioned, to define this. And the nano-define consortium defined that everything what is electron microscopy is currently the best techniques ready to give a number-based information. And this is applicable to raw material themselves as well as to finished product. And the OECD published in 2023 also the guidelines, also relying on this type of method as a very reliable method to measure if a nanomaterial or if a material is nano or non-nano. So I guess we are in the good way, to get means to identify and measure the size in the raw materials and in finished product. And as was mentioned, nano is allowed. I mean, in Europe, it's just a labeling as indication and not as warning. So often it's an emotional point of view from the consumer, but it's worth mentioning that it's just mentioned as an indication or information, and not
Information,
at all
not
about
warning, because a warning is not needed.
Yeah.
Fabulous. So we've got a question in which I really love. I like this one a lot. How is the skin microbiome affected by UV filters? Is it affected, and how? Eve, would you be interested in answering that one?
Yes, I can do so. So what we did in the past, because we were also interested if there's any kind of impact, we have tested different formulation with different UV filters and concentration and the placebo on the microbiome of humans. So, and we have figured out that before the treatment, we have measured the microbiome, so meaning what bacteria were part of the microbiome, and then we have applied the placebo and the different sunscreens, and we could see that there was no impact, which was for us at first very important to understand that the use of sunscreens in a formulation itself, it's safe. So it has no negative impact on the combination of the microbiome. Of course, we always have to say it always depends on the final formula, as for everything. But the first things we could say in a normal formulation with normal concentration, allowed concentration, we have not seen a negative impact on the microbiome. So consumer could use sunscreens and protect the skin against sunburn and aging.
Fantastic. And we've got one that's come through asking, what are your thoughts on reef-safe sunscreens? And is there an increase in alternative ingredients? That's maybe a little bit controversial. Does anyone want to answer that?
I can maybe say just a few words because it's in the line with it's the following step of the EcoSun Pass. Let's say that often the environment is connected to corals, and these actually unfortunately the corals die. This, is due to climate change and like temperature increase or ocean acidification, and sunscreen appeared in this discussion because they might have an effect because they are directly released in the ocean or in the water, and the full discussion started because of some publications, but these publications the design is not suitable to make such a conclusion, and unfortunately some government took drastic decision to ban some UV filter molecule, what is also questionable regarding then the health of consumer finally. And what we can say is that there is unfortunately no standardized test now to really answer this question, which filter is or is not impacting corals, but stakeholders are working on that. So there are groups created really to develop standardized tests and not a single test somewhere. So to really get a full picture on this topic. Because it's of course an important aspect of environment protection. So this is what I could say from our side.
And that was really a big part of the FDA coming in and regulating the UV filters and ingredients because we're concerned about the effects, especially on the coral reef. So that had a large part to do with why all of this is even happening.
And this is really sorry, I only wanted to say this is really the good thing that, as Miriam said, that stakeholders work on this, so Cosmetic Europe and suppliers and so on. So it's really good. So we have all seen and understood that we have to work on this to make a clear statement one time. So it will take time as well.
Fantastic. So I'm going to take us in a slightly testing direction right now. So Chelsea, we've got somebody here asking, how does your in vitro SPF compare against in vivo SPF, particularly for mineral formulations?
Let's see. In vitro and in vivo can either be exactly the same or differ a lot. It really depends on the consistency of the product, how well it applies to the in vitro PMMA plate, etc. There is a lot of times where the product does perform well on in vitro testing, but unfortunately does not yield the same results for in vivo, as we know that the human skin is much different than a substrate plate. We have seen cases where the in vivo performs higher than the in vitro and vice versa, but the only true determination for the performance of your product is an in vivo panel. That is truly what you need in order to make a claim, and that is the most important part of how it's going to perform on the human subjects versus the in vitro.
And we have somebody asking, how do you determine the PA 4+? What kind of test is necessary for this?
So the PA rating is derived from the UVA PF value of the product. So that 1/3 ratio that we were talking about earlier in the presentations, that value can come from either ISO 24443, which is the in vitro method for ISO, or it can come from the ISO 24442, which is the in vivo for the UVA PF. So we can get it from either the in vitro or the in vivo panel, and it just comes from the UVA PF value. There's different ranges. So for example, from 4 to 6, it would be a PA plus, and anything above a PFA value of 16 or more would be a PA with 4 pluses. So it just depends on the actual UVA value of the product.
Well, I hope that answers that question. Lovely. So we kind of slightly covered this in different ways, but someone is asking here, how can we formulate without chemical UV filters, with, again, zinc oxides, for instance, and not get a white cast? What are the ways around this?
$1 million question. I can talk on from actual testing standpoint. We have seen many products that have come in that are strictly zinc or mineral or have some form of oil in them. I will say that 9 times out of 10, unfortunately, they do not perform as expected. It is extremely hard to get a high performing SPF with just using zinc without any other SPF boosters. But that is why I did speak on earlier that the clients will send multiple iterations of the same product just with different levels of zinc, because it is very hard to get a product to work without the white cast with just using zinc. So that is a big topic of how we're trying to formulate products now moving forward.
Lovely. So to round up, we have a question here. I really like this one. How do we future-proof our products through the selection of UV filters, which kind of sums up what we've been talking about today and the theme of this webinar? So yeah, how do we future-proof our products here?
So from our point, again, from testing, it's very interesting for us because we are still unaware if the monograph changes are going to affect products that are already marketed and labeled, meaning are we going to have to retest all the products? Are the clients going to have to replace their filters and ingredients that are no longer allowed, etc. So we're just waiting to kind of see what's going to happen. We did have a pause in testing for a while when the news first came out because everybody was waiting to see what was going to happen. They didn't want to begin, which is a long, expensive process of formulating a product, if in 3 months we were going to get news that you could no longer use those ingredients and filters. Now that it has been so long and a decision has still not been made, we are seeing an uptick in formulations and submissions. But until we know for sure, I'm sure that there really is no way to future-proof unless we know exactly what kind of ingredients will and will not be allowed to be used.
Yeah. Maybe I can comment from the performance point of view. and what we can expect for future sunscreens in the future. So you have different aspects you can consider, of course, if you want to future-proof your product. It's to avoid the filter, maybe under discussion today. And to choose the filter that are seen with high molecular weight, for example, and photostable, that you know that will have no negative or adverse effect. From the performance point of view, I guess what is missing and is the UVA protection that can be increased. I mean, we speak a lot about the race in increasing the SPF, but neglecting a bit the UVA part that we have seen and we know today has a long-term effect. So maybe go in the direction of more uniform protection, and of course without forgetting the environmental aspect for the future.
And I would also say, finally, we have to find compromises, I would say. So safety for humans, safety for the environment, and then to accept also that formulation maybe change their textures. So when it comes to hybrid or to zinc oxide formulation, so maybe to accept white case or something like this. So I would say we really have to work on this. And besides of UVA and UVB rays, we of course have the visible light and the infrared protection on top to our formulations. So I would say there's still a big room to improve and to learn, and happy to have new formulations and textures in the future.
I look forward to seeing them too. Fantastic. So unfortunately, that is all we have time for today. Thank you so much to our panelists for all of your insights there. It's been really, really interesting. To our viewers, thank you for joining us too. And apologies if we didn't get around to your specific questions today. As mentioned at the start of the webinar, maybe if you're a bit late to proceedings and missed the first part and would like to catch up, this webinar will be available on demand. Our next roundtable webinar will be on the 13th of June and on the topic of fragrance. There is a sign-up box in front of you, so make sure that you don't miss out. And if you are yourself an expert in this field, you can register interest in a speaker slot, like our experts here, via our Q&A box. So with all of that said, I would like to extend a huge thank you to all of our speakers who've been fantastic. And thank you to our audience too for watching. Goodbye.
Thank you.